Hi everyone. I am taking a big risk with this video, and I know that. I'm very aware that this is a very sensitive, politically charged topic of climate change. And while it is risky, I have to say I think it is also extremely important. Not only is it important with regard to the context or the potential impact of the human role in climate change, but it's also important because we just need to know. I think that what's going on with the world is something that it's good to understand. It gives us good peace of mind if we can kind of get our head around what's going on. And I don't buy into this argument that it's just all so complex that we can't even conceptualize or really understand. Just trust the scientists. They know what they're talking about. They've been trained. This is horrible, and humans are the reason. So I think if we dig in, and this video is not intended to necessarily change your perspective, it only covers a couple, one or two really, components of CO2 specifically that I think are valid as a part of any normal person's decision process when it comes to forming an opinion about climate change, okay? And that's it. All right, take it or leave it, but I'm going to do this as quickly as I can, just run through a couple of slides. I'm going to use PowerPoint for this because there's pie charts and things like that involved, okay? First of all is the chart that we've all seen since grade school talking about the CO2 cycle of life. There's cows and trees, and the trees break down, and then microbes eat the trees and the cows that die, and that creates CO2. There's a lot of things in the environment that create CO2, but always there's this huge weight on the human element: agriculture, industry, trucking, cars, and airplanes. The huge contribution of humans to CO2. But very rarely do we understand what the true contribution of humans is relative to nature's contribution to CO2. What I've found, and I've looked in a lot of places, I've actually spoken to a climatologist about it, and I've tried to figure out what exactly is the human contribution to CO2. And here's what I found. In general, and this number could be as high as 5, it could be something below 3, but 3% is the number that seems to make the most sense. Most people believe it. And I'm saying this very vaguely because nobody really knows. But I think it's absolutely irresponsible for a lot of people in the media and even in climate science to come out and imply that there's this overwhelmingly large contribution of humans to the total environmental creation of CO2 in the atmosphere, okay? 3%, all right? And that's not to say that that makes the argument of CO2 and the human contribution irrelevant, because what climate scientists are saying is that humans are contributing enough that it's going to take us, or has taken us, to a tipping point where the balance on Earth and in the atmosphere has been shifted, and it causes kind of a spiral effect. Okay, warmer weather leads to more evaporation, leads to more clouds, leads to more CO2, leads to more, and so forth, and it gets out of control. And so 3%, I think, is a reasonable number, and I think that's very close to being accurate based on everything that I've seen. All right, but there's other things that we need to add here real quick. First of all, volcanoes, and if you ever add volcanoes to your equation, you must be very specific. Volcanoes do create a lot of CO2, but they do not create many, many, many times more than humans create. What is important to note is that volcanoes create not only CO2, but methane, other gases. Of course, there's water vapor that come out of there. That's a greenhouse gas. There's also ash and particulates that get shot way up in our atmosphere and stay there for years. And so when you hear someone say volcanoes have a far higher impact on climate change than humans, they should not be using the word CO2, because if you combine everything from a volcano, you're correct. If you're just looking at CO2, not at all correct. Okay? Just want to make that clear. And then there's things like termites. There's been more than one study looking at bugs and the impact of bugs on CO2, and specifically the termite, because termites eat wood. they break down wood and fiber of all different kinds. And when they do, the byproduct is CO2. It turns out, after a controlled study of a certain number of termites, they determined how much CO2 is generated per day, per hour, etc. And then they tried to make an estimate of the number of termites on the planet, and they found that termites produce 10 times as much CO2 approximately as humans do. Now, that's a big number, but let's say that's even wildly exaggerated, and one bug on the entire planet is creating 5 times as much CO2 as humans. That still kind of gives us a good context or perspective on the human impact on CO2 in our environment, right? So high level, this is a graphic look at it. The main thing to take away from this page is 3%. Let's move on. Couple of pie charts. This is a very common one. 64% carbon dioxide in the atmosphere, and of course this is only listing greenhouse gases. So when you see this and you think humans are contributing 3%, you say, well, that's still significant because CO2 is 64% of all the greenhouse gases in the atmosphere. Thing is, this leaves something out. It leaves out water vapor. Water vapor is by far, and you notice there's no numbers on this, by far more prevalent and more powerful in the atmosphere as a greenhouse gas than CO2 or any other greenhouse gas. The reason it doesn't get included is legitimate. It is highly volatile. Water vapor is not standardized. It's not a constant. It is up there, but different seasons, different times of year, different altitudes, so many variables to determine what the density of water vapor or the content or percent of water vapor in the atmosphere is. It's different in different regions of the planet. If you work with an average, the average changes hourly depending on what's going on with the weather around the planet. So most scientists eliminate water vapor in their discussion. That makes sense, but it's very important that we remember the importance of water vapor to global warming, okay? All right, moving on. Next pie chart is one that shows oxygen, 21%, nitrogen, 78%. These are not greenhouse gases, but this is a graph showing all the gases in our atmosphere, okay? Nitrogen and oxygen predominantly, and then you have 1% inactive gases. But what is that 1%? And by the way, as the note says, there is no water vapor in this. So don't assume that a huge percent of the 1% is water vapor here. That's not the point, okay? But again, as usual, water vapor is not included in scientific documentation, okay? Or it's a side note. All right, let's take a look at what NASA says. This came right from NASA. And so here in the pie charts, you can see 78% nitrogen, 21% oxygen in the dark blue. And then if you go into the 1%, it's expanded out. And wait a minute, what's that yellow stuff? Argon. So if we look at the chart on the left, you can see argon is 0.933%. So 93% of the 1% is argon. That leaves a very small amount for all greenhouse gases, okay? Except for water vapor, again, is left out of this. So here we are. Now let's look at carbon dioxide. 0.034% of that 1% is carbon dioxide. It's very, very small amount of our atmosphere. How powerful does CO2 have to be in order to have significant impact on global warming? Okay, but then remember, this is not the point. CO2 could be causing warming, all right, even at that small amount. The real question is, what's the human impact again? Because the claim of climate change alarmists is that not only are humans causing the unusual increase in global warming, but that we can reverse it, right? So if we work with that 3% number we saw in the last slide, the human contribution of CO2 to our atmosphere in total is 0.001%. All right? And you can double it, okay? If that makes you feel better, let's go 0.002%. But even with that, what are we going to do? We're going to spend billions and billions and billions of dollars trying to reduce that by what, 30%? And expect that to have some sort of an impact. So I'm sharing this just to let you know and to hopefully give you some context around what these people mean when they're talking about humans causing global warming through human contribution to CO2 in the atmosphere. Okay? It's just extreme. All right, so when global warming people approach us and ask, are humans responsible for pumping an increasing volume of CO2 into the atmosphere every year? The answer has to be and can only be, of course that's correct. Okay? But then they follow up with another question. If it is true that humans are generating CO2 at an increasing rate, it is, and that CO2 is a greenhouse gas, which it is, can we agree that humans are responsible for global warming? Well, the answer, of course, is that we have to. But the problem is that this is the wrong question, and I'll show you why. I always answer this second question with a question. If I toss a pebble into the ocean, am I responsible for the increase in sea level? And the answer is yes. It doesn't matter how tiny that pebble is. If I throw that into something as vast as the ocean, I am increasing the volume of the ocean, and therefore I am responsible for an increase in the level of the ocean, the sea rise, okay? I don't think that is even a measurable increase in sea level. But it is still true that I added volume, therefore I rose sea level. All right? The same thing is true with this question. You cannot deny that humans are adding CO2. CO2 is a greenhouse gas. Greenhouse gases warm the planet, so humans are responsible for global warming. The problem is this question is completely irrelevant. The amount of CO2 created by humans does not have a measurable impact on the climate, according to the percentages that I just saw, unless CO2 is way more powerful than has been explained to me. But there is one more question that is good to consider if you're trying to get real context on CO2 in our atmosphere. Is the current level of CO2 on the planet high, medium, or low? Wouldn't it be strange if we were trying to reduce the level of CO2 on the planet if it was already low and increasing to a normal level? And how will we know that? Well, here's a couple things to consider. During seasons where weather is still and air is not moving, plants in the middle of fields have been seen to grow far slower than plants on the edge of the fields. This is because plants are literally suffocating due to low levels of CO2 available. Okay? These huge farms with these great big fields like we see in the picture here, if there are times in the summer where the wind is very low and the plants in the middle just do not grow very fast. In fact, they're more disease prone, they produce less fruit, and so forth. So they started doing studies, and this is what they found. CO2 levels are much lower. The plants on the edge of the field are using it all, and the plants in the middle of the field have none to help them grow and stay healthy. Meanwhile, the opposite is also true. By dramatically increasing CO2 levels in greenhouses, the plants grow much faster. They have better health, and they produce higher quality products. Okay, and this is a picture of dry ice being hung in baskets, and as it melts and vaporizes, it's dropping massive amounts of CO2 into the greenhouse, and the plants just eat it up, and it makes them grow a lot faster, a lot healthier, and make better product. So the bottom line is that farmers know that CO2 sustains life nicely on the planet now, but more is actually better. And humans survive just fine in much higher levels of CO2 than what we're seeing outside today. So the bottom line of this is that plants actually thrive far more with significantly higher levels of CO2. And this leads to larger plants creating more shade, which creates cooler microclimates under the plants and under the canopy. Also, there's more biomass on the ground from leaves falling and dead limbs falling and so forth. This leads to a much richer cycle of life on the ground, microbes and plant life composting and bugs dying in the weeds and things like that. And then shade also leads to lower water evaporation into the atmosphere. And we've already shown that water vapor is by far the most prevalent greenhouse gas in our atmosphere. So the truth is that CO2 creates larger plants, creates more shade, and reduces evaporation, which reduces the amount of clouds in our atmosphere. One more factor I couldn't resist putting into this video, and that is phytoplankton. Oceans store CO2 in case plants eat too much. We've seen that. You've probably heard it in the news. They've been measuring CO2 in the ocean and so forth, right? But phytoplankton is the foundation of the ocean's ecosystem. These are the plants of the ocean, and they are as diverse and unique as the plants on land, trees and grass and so forth. So think of them like that. These are the plants of the ocean. Several studies have concluded that phytoplankton is actually responsible for as much as 85% of the oxygen in our entire atmosphere. So now you just take all the trees and grass and plants on land and eliminate them, because 85% of all the oxygen created is done by these little guys, which we can't even see floating in the ocean. And I say we can't see, but there are some phytoplankton that can be seen, because they're luminescent in some sort of way. So this is a picture of some of these phytoplankton in a bloom because something has happened. Now, a lot of the climatologists will tell you that this is a clear example of CO2 in the water, which makes these things divide very fast. And while that's true, there are really three elements that make these phytoplankton multiply extremely fast. One is warmer water. Perhaps there's some sort of a underwater hydrothermic vent or something like that that's warming it and making them divide like crazy. Also an increase in just general nutrition in the water, combined with warmth perhaps, makes a big bloom. And then the third factor is CO2. CO2, as we know with trees and plants on land, is critical to cell division and plant growth. But there's a lot of factors, in other words, three primary, that make these things happen. This is an area where it's happened. If we ever start to see that our entire oceans, or at least an entire band around our equator, is lit up like this light blue area, then is when I'll start to believe that CO2 is out of control and the ocean cannot handle the volume of CO2 that is being absorbed. Okay, so that's enough on CO2. My goal here is to share data that might help us all understand which questions we should be asking. For instance, what is the safe level of atmospheric CO2? See if you can get a scientist to answer that one. Okay. Number two, is it possible to reverse the current trend and achieve that level, whichever level they tell you is a safe level of CO2? It's been my experience that they say we don't know, or every little bit helps. But they don't ever seem to say that we can get to a safe level. We can reverse this trend by spending billions and billions of dollars, changing our lifestyle entirely. If we could do everything that they want, could we actually get back to what they consider a safe level of atmospheric CO2? And that's a very difficult thing for them to answer, because as I've just shown, it's highly likely that CO2 levels on Earth should actually be higher. All right? But anyway, just a couple of questions to ponder, and I hope I brought the reason why these are important questions out as a part of this video. One last note. I'm not saying don't recycle. This is something we want to do to take care of our planet, despite whatever global warming is doing. Okay? Anyway, with that said, I hope this was helpful. I hope it was meaningful, and I hope it wasn't too long. If you like this content, there are a lot of other similar topics that I could cover about CO2, or data points that I could mention. So I'd be happy to create more videos if you like this. Thanks so much, and have a great day.